In our next module, we are going to be looking at solving quadratic equations. And the first technique that we're going to use will be using the zero factor principle. This principle says that if you are multiplying two items and the answer that you got is 0, at least one of those factors that you were multiplying had to be a 0. We are going to solve these given equations by using the zero factor principle. In order for the factors of x plus 5 times x minus 1 to multiply and equal 0, one of those factors has to equal 0. So in order to figure out what those possible answers are, we take each factor, the first one of x plus 5, and set it equal to 0. And then take the second one of x minus 1 and set it equal to 0. Now you have two little equations to solve. Subtract your 5 on the first one, you get x equals negative 5. Add 1 on the second, you get x equals 1. Either one of those values, if we put them into the original equation, would work and give us an answer of 0. On our second example, we have the quantities of 3 minus 2w times 4 minus 5w equals 0. Our zero factor property says set each of those factors equal to 0. Now we've just got two small equations and we need to solve each one. On the first one, I'm going to add the 2w to both sides so that I have a positive variable. So I get 3 equals 2w. Divide both sides by 2, we get w equals 3 halves. On the second one, I'm going to add 5 since my w term is already positive. I now have 4w equals 5, divide by 4, and I get w equals 5 over 4. On our next example, we have 2x on the front times the quantity x minus 3 times the quantity x plus 4 equals 0. When you have an item on the front, as we do here, if that item contains a variable, then you must also set that factor equal to 0 because it is possible for that to equal 0. So we're going to start out by setting 2x equal to 0. Then we're going to set our first quantity equal to 0, x minus 3 equals 0. And then our second quantity of x plus 4 equals 0. So this time we have three little equations to solve. On the first one, we're going to divide by 2, and 0 divided by 2 is 0. So we get a first possibility of x equals 0. On the second one, we're going to add 3, and we'll get x equals 3. On the third one, we're going to subtract 4 and get x equals negative 4. I chose the next example specifically because it also has an item tacked on the front, but notice that that item does not contain a variable. When what's on the front is a constant, a plain number, you do not set that equal to 0. It doesn't even make sense to say negative 6 equals 0. You only use an item on the front if it has a variable. So in this case, we are only going to use the two quantities. So we're going to set y plus 2 equal to 0 and 3y minus 5 equal to 0. Subtract 2 on the first quantity, you get y equals negative 2. Moving to the second equation, we're going to start by adding 5 and get 3y equals 5. And then divide by 3, and we get y equals 5/3. For example 2, we're going to have several problems where we need to solve the equation by factoring. We are still going to use the zero factor principle, it's just that we're going to have to factor the problem first. Notice on this example, 2y squared equals 10y, that it's not equal to 0 yet. We generally want our squared term to be positive if possible. So I'm going to subtract 10y and make this equation into 2y squared minus 10y equals 0. Now I do have an equation that's equal to 0. And when I look at those two terms that I have on the left side, they both have a common factor of 2y. So we are going to factor out a 2y. If we take 2y squared divided by 2y, what's left is y. If I take negative 10y divided by 2y, what's left is negative 5. And that is still equal to 0. We pulled out a 2y. We have to ask ourselves, is there a variable in that? Should I use it? Yes, it has a variable. So we're going to set that item of 2y equal to 0, and then set the quantity of y minus 5 equals 0. Divide by 2 on the 2y equals 0, you get y equals 0. Add 5 on the y minus 5 equals 0, you get y equals 5. Our next example is another two-term equation. This one is already equal to 0. And when you have two terms, you have to check, is there a common factor or is it a difference of squares? This one is a common factor problem. 6 and x go into both of those terms. So we're going to factor out 6x. If I take 6x squared divided by 6x, I'm left with x. If I take 18x divided by 6x, I'm left with 3 equals 0. Does the item that we pulled out to the front contain a variable? Yes. So we are going to use it and set 6x equal to 0 and x plus 3 equals 0. Divide by 6, you get x equals 0. Subtract 3, you get x equals negative 3. This is our first example where what we are given is a quadratic, and it is unfactored. So we have to see, does this factor? This will factor into v plus 2 times v plus 2 equals 0. Notice that both of our quantities are exactly the same. It's not necessary to write the same quantity equals 0 twice when your quantities are the same. So we're just going to set v plus 2 equal to 0 one time and solve that by subtracting 2. We get v equals negative 2. On the next problem, we have x squared minus x minus 20 equals 0. Another unfactored quadratic. This factors into x minus 5 times x plus 4 equals 0. Set each factor or quantity equal to 0, so we have x minus 5 equals 0 and x plus 4 equals 0. Add 5 on the first quantity, get x equals 5. Subtract 4 on the second and get x equals negative 4. On our next problem, we have 5y squared minus 7y minus 6 equals 0. This problem is a little bit harder to factor. We do know that our only possible factors of 5 are 5 and 1. And then factors of 6, let's try the 2 and 3. If we put plus 3 and minus 2, on the outsides, we would have negative 10. On the insides, we would have positive 3. Negative 10 plus 3 gives us our negative 7 for the middle. Set that equal to 0. Now, set each quantity equal to 0. So 5y plus 3 equals 0. Y minus 2 equals 0. On the first quantity, subtract 3. You're going to have 5y equals negative 3. Divide by 5, you get y equals negative 3/5. On your second quantity, add 2, you get y equals 2. What's different about this equation is that it's not equal to 0. Notice that our squared and x to the first terms are both on the same side already. So we're going to move that 9 by adding 9 to both sides and get 4x squared plus 12x plus 9 equals 0. Now we need to factor this. This will factor into 2x plus 3 times 2x plus 3. Remember earlier we had a problem where the two factors were the same. When they are the same, you only have to write it down one time, 2x plus 3 equals 0, and solve it one time. Subtract your 3, you get 2x equals negative 3. Divide by 2, you get x equals negative 3 halves. Our next example is also not equal to 0. In this case, our squared term is already on the right side and positive. We want our squared term to be positive if possible because it makes factoring so much easier. So in order to make sure that squared term stays positive, I'm going to add 30 to both sides and put the 0 on the left. So I'm going to have 0 equals 9v squared plus 30v plus 25. Factor what you've got. This factors into 3v plus 5 times 3v plus 5. We have the same factors again. When you get the same factors 2 times, it's called a double root, just for your information. Set that double root factor of 3v plus 5 equal to 0 and solve it. Subtract your 5, you're going to have 3v equals negative 5. Divide by 3, you get v equals negative 5 thirds. We are going to have problems where there is simplification of some type that must occur before you can factor and solve the problem. The instructions will tell you to simplify and solve by factoring. When you look at this first example, notice that we have a quadratic equation on the left side. On the right side, it's kind of a quadratic because it's a squared, but it's a quantity squared. So before you begin, you need to multiply and remember that y minus 6 quantity squared is y minus 6 times y minus 6. Our left side's going to stay as it is, 2y squared minus 21y plus 50. Do the FOIL on y minus 6 times y minus 6. You're going to get y squared minus 12y plus 36. Well, now the problem is this is not equal to 0 for us to be able to solve this. So we are going to take all the terms on the right side and move them to the left side. I'm choosing to do this because my y squared is smaller than 2y squared, and I want my squared term to be positive if at all possible. I'm going to start by subtracting y squared on both sides. I'm going to add 12y to both sides. And I'm going to subtract 36 on both sides. Now, 2y squared minus y squared leaves me with y squared. Negative 21y plus 12y gives me negative 9y. And 50 minus 36 gives me positive 14. And then because we subtracted everything from the right side, we have equals 0. Now this that's left on the left side does factor into y minus 7 times y minus 2 equals 0. Set each of those quantities equal to 0 and solve. We get y equals 7 and y equals 2. Our next example is very similar, but what we need to FOIL is on the left side this time. Remember that we need to do x plus 3 times x plus 3 since it's the quantity squared. Doing that FOIL will give us x squared plus 6x plus 9, And the right side is going to stay unchanged as 2x squared plus 9x plus 11. Our bigger squared term is on the right side this time. So we're going to get our 0 on the left side by subtracting every one of those terms from both sides. So we're going to subtract x squared on both sides. We're going to subtract 6x on both sides. And we're going to subtract 9 on both sides. Now we have 0, because we subtracted everything from the left side, equals 2x squared minus x squared is x squared. 9x minus 6x gives us 3x, and 11 minus 9 gives us 2. This factors into x plus 2 times x plus 1. Set each of those factors equal to 0, and then solve each. For the first quantity, we get x equals -2. For the second, we get x equals -1. The last kind of problems we will be asked to solve by using factoring will have two quantities, and each quantity will have something that you can do to it. On this problem, the first quantity is 2w plus 10. But notice that that has a common factor of 2. So we're going to pull 2 out of that. If you take 2 out of 2w, you have w left. If you take 2 divided into the 10, you have 5 left. The second quantity is w squared plus 6w plus 5, and that factors into w plus 5 times w plus 1 equals 0. On the very front, we have a plain 2. There is no variable with it, so we are going to ignore it. Our first two quantities are exactly the same, so we don't need to write them down twice. We're just going to say w plus 5 equals 0 one time, and then our other different quantity is w plus 1, and set that equal to 0. Subtract 5 on the first quantity, you get w equals -5. Subtract 1 on the second, you get w equals -1. Our next example is very similar to the one that we just did. When you look at that first quantity, there's a 5 that goes into both terms. So we're going to pull out a 5. 5v divided by 5 leaves us with v. 35 divided by 5 leaves us with 7. The second quantity of v squared plus 3v minus 28 factors into v plus 7 times v minus 4 equals 0. Again, what's on the front is a plain number, no variable, so we're going to ignore it. Our first two quantities are the same, so we're only going to use it one time. V plus 7 equals 0. Use the different quantity of v minus 4 and set it equal to 0. Solving each of those little equations, we get v equals -7 and v equals 4.